Hello everyone, my name is Meredith Palmer, and I'm a conservation technology specialist at Fauna and Flora International, joining you here today from the Old Pejeta Conservancy in Kenya. And I've spent the last decade of my life using camera traps and other technological tools to peer into the secret lives of wildlife. And now I work with engineers and computer scientists to innovate new hardware and software tools, so think drones and satellites and artificial intelligence, to overcome critical conservation challenges. And so what I'll be talking to you about today are some of our new advances in conservation technology and how we use technology-enabled solutions to protect wildlife and wild places. So first of all, what is conservation technology? Technology and wildlife might not be things that we often associate with each other. More often than not, new technological advances have been responsible for contributing to the destruction of nature rather than its preservation. But increasingly, technology has become an incredibly essential component to modern biodiversity conservation. So with huge challenges like wildlife crime and poaching and climate change and deforestation and extinction threatening ecosystems around the world, technology has the potential to revolutionize conservation, enabling us to collect more and better data to rise up to these conservation challenges. So the new tools that we have, our camera traps, acoustic sensors, drones, biologgers, and satellites, all provide new and improved ways of monitoring wildlife, their habitats, and their threats, empowering conservationists to better manage and protect the systems in which they work. So conservation technology then, that term, we're referring to the application of tech to environmental challenges, and this is a really exciting, new, and rapidly developing field of study. So in terms of types of tech we use in conservation, so many different types of tech. I've mentioned some of them, things like wildlife camera traps, satellite remote sensing, geographic information systems, environmental DNA, artificial intelligence, the Internet of Things, mobile apps. You know, most technologies that are out there, we're trying to find new ways to use those tech to help us protect wildlife. So these tools, what they're doing for us, they can provide novel data sources, they can expand the spatial and temporal coverage over which we're able to monitor wildlife. They help us access real-time information about what's going on in nature. And they also provide avenues for rapidly processing and analyzing all of that data we get back. So turning that data information that we can use for conservation interventions or to help guide data-driven conservation strategies. And so what I'm going to do now is just quickly run through some of the devices that are being used here on the ground at Old Pejeta Conservancy to help protect the incredible biodiversity in this region. So just as a little background, Old Pejeta is a 90,000 acre wildlife sanctuary located in Kenya's Laikipia Plateau. So we're right at the foot of Mount Kenya. You might be able to see it behind me. This reserve supports the largest rhino population in Kenya, including the 2 remaining northern white rhinos, the last 2 in the world, in addition to a massive diversity in biomass of other species. And importantly, Old Pejeta serves as a role model for innovative conservation, particularly through the work of their conservation technology lab. So there's an entire lab here, an entire unit dedicated to designing, developing, and deploying cutting-edge tech, again, to stay at the forefront of conservation innovation. So here at Old Pej, there are a number of different technologies that we use to monitor wildlife and wildlife threats. The first of which I'm going to talk about is the camera trap. And so camera traps are now a fairly common type of wildlife monitoring technology, but when they really started to take off and grow in popularity a few decades ago, they just completely revolutionized how conservationists study free-ranging wild animals. So a camera trap is fairly simple, a humble even device. It's a rugged camera which you can deploy in the field. So you'll go out, you'll strap it to a tree, and it takes a picture or a video whenever a passing animal triggers its infrared sensor. And then the image that you get back, that is your data. That is a permanent record of species presence in a particular area at a particular time. If you look at that photo, you can tell how many of that animal there were, what they were doing, things like whether they had offspring with them. In some cases, you might be able to identify the animal sex or even get an idea of how healthy they are. and record some very interesting behavioral interactions. And because these cameras are non-invasive, by which I mean people aren't required to operate them, there's no one out there pressing the trigger 24 hours a day, the camera traps can be deployed for very long periods of time in remote habitats, capturing animals that are rare and cryptic or don't come out during times when researchers and managers would typically be around. And excitingly, camera traps have led to a huge number of major discoveries. And this is everything from documenting new species, documenting new behaviors. For instance, a camera trap survey that we set up in neighboring Tanzania, we discovered a species of bird that roosts at night on the undersides, like right up in the armpits of giraffe, instead of sleeping in trees like normal birds should. And because we don't go out at night, we don't monitor giraffe at night, we never would have had an inkling that this kind of behavior existed without our camera trap photos. And so beyond rare events, cameras are typically used to document wildlife presence, abundance, look at population changes, particularly in the face of land use or climate change. They're relatively inexpensive, easy to operate, and again, provide a window into a world that most scientists, let alone people, rarely get to experience. So that's camera trapping. Another form of technology used here is acoustic monitoring. So this is a passive acoustic monitor, and it's a device that operates on very similar principles to the camera trap. But instead of capturing images, the acoustic monitor is capturing sound. So just think about how much information could be learned about you by listening to the noises that you make. Well, monitoring the soundscape of an environment can reveal incredible things about the biodiversity that's present in a landscape. You can probably hear a lot of wildlife behind me at the moment. There's birds here. You might hear the elephants in the background. Monitoring the soundscape of the environment can tell you a lot about not only the species present there, what they're doing, but also a little bit about the humans in the environment as well. So while not all animals vocalize, many of them do. So many species of birds, especially frogs, fish, mammals, whales, use calls, whether humans can hear them or not. They can be ultrasonic, they can be infrasonic, but they use these calls to communicate with each other, information about mating, information about territory defense. Maybe they're producing sounds in order to navigate, like bats or whales, or just making sounds during everyday activities like feeding, which again are being broadcast into the environment that we can pick up on. Like I said, some human activities, including illegal activities, can also be detected acoustically. So for instance, the sounds of gunshots in a national park, chainsaws in a protected forest, blast fishing in a marine protected area are all detectable signals that can be picked up by acoustic monitors. So an acoustic monitor is simply a microphone and a recorder that, again, like the camera trap, can be deployed non-invasively in the field to eavesdrop on the acoustic environment. They can tell us about species presence, who's here, who's not. Very good for detecting wildlife that's elusive and out of sight. Like with camera traps, again, you can use these detections to track trends in animal occupancy, so where they're living, their abundance, how many of them there are, biodiversity, how many different species you have in the environment. And you can also get some really cool things like how vocal communication in animals changes, so call repertoires or variation in calls among individuals. So listening in on the signals that animals broadcast about themselves into the environment, very rich but underappreciated source of ecological information. So that's acoustic monitoring. Another device that we're using here on the ground at Pejeta is tracking collars, wildlife monitoring collars. And so these are a transmitter that's put on a belt or a collar. You attach it to an animal's neck or ankle, and that enables you to monitor where individuals are going and what they're doing. This allows researchers to understand a whole host of ecological information about specific individuals. So their home range size, their movement behavior, their interactions with other animals sometimes, things like their diet even. And there are two main types of collars that we use as wildlife ecologists. VHF collars, and GPS collars. So VHF stands for very high frequency. And what the VHF transmitter on the collar does is that it sends out pulses of radio signals. And so you, as a researcher, can go out with your little receiving antenna, listen to those signals, and hone in on that animal's location. And so these collars tend to be a little bit less expensive, a little bit more reliable, tend to last a little bit longer in the field than GPS collars. But the downside to using VHF is that you have to actually physically go out into the field to locate your study animal. So GPS tracking collars, on the other hand, allow for remote detection of an animal's position. So the GPS on the collar records where the animal is, records locations at set intervals, and then stores or even transmits that information to the researcher, to the receiver. And if your information is being transmitted, you can simply download the data onto your computer, onto an app, and you know where your animal is and what it's doing. And the really cool thing about GPS collars is that it allows you to collect data during any time of the day or night, and log those locations at regular intervals. How often you're getting a location, so how often your collar is pinging a satellite with that data, depends on how long you want the battery to last. So typically with wildlife, we don't want to put a biologger or a collar or a sensor on an animal that weighs more than like 3 to 5% of the animal's total body weight. We don't want them dragging around this massive piece of equipment that's going to impede their natural behavior. So big whopping batteries are just out of the question. We can't do that. But changing the battery is also a little bit problematic, because in order to do anything to the collar, you have to capture that animal and put it down while you attach or replace whatever equipment you're interested in, which, as you can probably imagine, a little bit distressing to wildlife, so you don't want to be changing your batteries every week either. So got to find that good balance between obtaining data at a fine enough scale for you to answer your research or monitoring questions, but that allows your collar to last for at least a couple of years so that you're not unduly distressing the wildlife that you're trying to protect. And so I think for big cat monitoring here at OPC, we have some GPS and VHF collars on big cats, but our GPS collars, we're getting half a dozen fixes per animal per day. What else about GPS collars? So addition to being a little more power intensive than VHF collars, they're a little heavier. You never have to see an animal when you're doing GPS fixes. So if you're interested in physically locating that animal and seeing them and checking in on their health or confirming certain behaviors, such as whether they're at a kill or whether they've had babies, some kind of activity like that, sometimes it's good to go and check on the animals in the field regularly rather than just relying on this remote sensing data. And I think one other thing to note in terms of emerging technology is that these days collars do a lot more than just send locations or transmit locations. Others transmit or collect a lot of different kinds of exciting data too. So people now are sticking on like accelerometers and gyroscopes, which can tell you how fast your animal is moving and in how it's moving in 3D space. Some collars often have mortality sensors that let you know if your animal has died. And recently, scientists have been doing fun things like attaching like GoPros and videos to collars as well, which enable you to see what an animal is meeting or who it's interacting with. So a real first-person POV, point of view, into an animal's life. So that's wildlife tracking collars. And the last tech that I want to describe to you in some detail that we use here are drones. So drones provide that eye on the sky, bird's eye view of wildlife populations that enable us to detect, count, and study their behavior from an entirely different perspective. So everyone probably has a really good mental image of what a drone is, but in the most basic sense, a drone is an unoccupied aerial vehicle that's flown by an operator on the ground. They typically carry a camera, sometimes a host of other sensors that send real-time information on species presence and abundance and activity, and not even species. So, as with some of these other monitors we've talked about, they can even collect and transmit information on the location of illegal activity, such as poachers or loggers or wildlife traffickers. Drones tend to come in for wildlife monitoring. You're going to get a fixed wing or a quadcopter version. So a fixed wing looks like a tiny airplane. A quadcopter has all of those rotating propellers on it. We use a quadcopter here at Pejeta to track wildlife, for example, when it wanders into thickets that are too dense for researchers to follow them. And this is one of the key advantages of drones, is their ability to go places and cover distances that would be difficult for humans to accomplish. Drone images also provide a permanent record of, for instance, animal counts. So they're very commonly used to census wildlife populations. Traditionally, you might census a wildlife population like the number of elephants or buffalo in your environment by hopping into a plane, looking out the window, and estimating how many animals you see. And when you're doing that as a human, we're very fallible. It's very easy to miscount animals, especially if they're in really large groups. But with drones, you can fly your drone over an entire herd, take a bunch of images, and then double check your counts after the fact. Other things you can put on drones. So other sensors might include things like multispectral or thermal sensors, so thermal imaging sensors, which detect the heat radiating off of animals or other things in the environment. And these are quite cool because they let you see animals at night in the dark or spot them through very thick vegetation like a forest canopy. Other drones might carry things like VHF receivers for those wildlife tracking collars. So you can actually go out, and instead of you physically with your antenna, the drone has the antenna, and you can track your collared individuals in really hard to reach places. Unfortunately, drones tend to be quite noisy, and the ruckus that they make can sometimes scare animals or cause them distress. So it's a tool to be used considerately. All right, so these are some of the exciting, but I would say maybe increasingly mainstream forms of conservation technology. And as I mentioned earlier, this is a rapidly developing field, and new kinds of tech are being designed and tested in this arena all the time. And so if you want a really great overview of some of these cutting edge devices, I really highly recommend checking out the online Wildlabs platform. So Wildlabs is a community of conservationists and ecologists and engineers and computer scientists and hackers and makers who all come together to solve critical conservation challenges using tech. And in a recent Wildlabs report, they identified 3 emerging technologies that conservationists are most excited about and see the most potential in. And these include eDNA, network sensors, and artificial intelligence. And so quickly, eDNA stands for environmental DNA, or the DNA traces the animals sort of shed passively into the environment. So this might be DNA from skin flakes or fur or droppings. And we as researchers can detect this if we then go and analyze the air or soil or water that this DNA has fallen into. And so even very small amounts of shed DNA can reveal if an animal is present in the environment. You don't have to take a picture or record a sound to see whether that animal is there or not. And because it's a little bit easier to sample soil than it is to set up 100 camera traps, this is a very quick and a very easy way to sample an entire ecological community and provide a very detailed snapshot of who's in your ecosystem. Network sensors. So these allow hardware devices, so your camera traps and your acoustic monitors and your animal tracking collars, to talk to one another. So the same kind of concept as the Internet of Things that connects your Fitbit to your smart refrigerator, to your smart toilet, whatever you have that's smart. And so you can, as a researcher, as a scientist, distribute sensors all across the environment, have them talk to each other, and this allows you to monitor the sights and sounds of an entire landscape in real time. And AI and machine learning, the last of these new exciting tools, these are becoming so essential in conservation research. All of the hardware that I've talked about, the camera traps, the monitors, even the eDNA, satellite remote sensing, these are generating absolutely massive quantities of data. Our ability to collect data at this point far outpaces our ability to process the data and turn it into meaningful and actionable information. So AI helps us sift through this massive trove of data, reducing the manual labor required by researchers to turn that data into conservation plans. So I, for example, run a couple of hundred camera traps in Tanzania, and I once sat down and calculated that if I myself, personally, one researcher, had to classify all of the images we collected in a year, so that is looking at each picture, writing down what animal is in the image, how many of them there are, what that animal is doing, it would take me 7 years to process the data collected in 1 year, a single year's worth of images, which is ridiculous. We can't use that information to then see how species are responding to critical conservation events or changes to their environment. And so with the help of AI that's been trained to classify animals in pictures, that workload, that 7 years, gets cut down to a matter of days or weeks. So AI, not infallible, not about to take over the world anytime soon, still requires a great deal of human labor to, say, set it up and train it in the first place. You have to retrain it all the time. But by integrating AI as a tool into our data processing pipeline, that was very jargony, I'm sorry, but by using AI to help us manage this data and tell us what's in all of the information we're getting from our sensors, that allows us to better react and respond to wildlife crises in real time, allowing us again to make more targeted and bigger conservation impact. And lastly, one thing I do want people to keep in mind when thinking about conservation technology, which is new and flashy and has all this amazing potential, is that we need to ensure that these tools are affordable, accessible, and that their use is equitable. So technology, again, has this potential to help conservationists better understand and mitigate critical environmental threats. But lack of accessibility of training and support and the sometimes high costs of tech mean that these advances can often be out of reach to many conservationists, particularly those who live in closest proximity to nature. And so thanks to cheap prototyping and designing tools, so the Raspberry Pi, if you've heard of that, is a great example of this, as well as cheap hobbyist 3D printers and computer boards, the cost of tech is becoming increasingly affordable, which is excellent. But despite progress being made in this direction, the knowledge to employ such tools is, again, not necessarily equally accessible, and that lack of knowledge is still a key barrier in deploying and using conservation tech, especially in countries with developing economies. And so that brings me to why I'm here in Kenya today. I'm incredibly excited to announce that we are in full swing of our first Kenyan Women in Conservation Technology course. So this is a 6-month program that my NGO, FFI, and Wildlabs and old Pejeta are running for early career female identifying Kenyan conservationists, providing them with foundational knowledge in conservation tech to advance their skills in conservation, to help spread awareness of novel solutions to their home organizations, and to also build a network of, this is the first wave of female conservation technologists. We want to help build and grow that community so that they can continue to support each other and empower each other in the field. This is going to sound a little cheesy, but it's so true. We believe that empowering underrepresented groups, that's what generates innovative ideas and novel solutions, and having those diverse perspectives engenders conservation success and helps innovate new solutions using these technology tools when applied to conservation challenges. So by putting these knowledge and tools in the hands of these women here, we're helping to ensure that conservation tech continues to revolutionize how we act to protect and conserve the natural world, and helps increase the impact that these cool tools can have on critical conservation challenges. So thank you so much for listening. I hope you enjoy the rest of the Biodiversity Festival.